Grounding RG-6 lines from a dish to a CATV panel requires careful attention to ensure safety and optimal performance. Firstly, let's discuss grounding the dish itself. Run a ground wire, typically 10 AWG or larger, from the dish to a cold water pipe located in the basement. Securely clamp the ground wire to the metal bracket of the dish. Ensure the connection point is well fastened with a bond clamp. Secondly, we will cover grounding the RG-6 lines. Install the ground block in the low voltage box where the RG-6 lines enter the basement. Connect the ground braid from the RG-6 cable to this ground block. From the ground block, run the ground wire to one of two possible options. Option involves using a cold water pipe. If there's another accessible cold water pipe in the basement, connect the ground wire to it. Make sure that the pipe is properly grounded and is not made of plastic. Option B involves using an electrical subpanel box. If a grounded electrical subpanel box is easily accessible, connect the ground wire to the green screw or grounding terminal located on the box. It is important to use copper wires or bond clamps for all ground connections. Ensure the ground wire is protected from physical damage and that it is not spliced or cut. It is also generally recommended to use separate ground wires for grounding the dish and the RG-6 lines to maximize protection. Keep in mind that if there is uncertainty about proper grounding procedures, it is recommended to consult with a qualified electrician. Grounding is an essential safety measure that should not be overlooked. The purpose of grounding is to provide a safe path for electrical fault currents to return to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. Grounding also helps to minimize electrical noise and interference, which can improve the performance of electronic equipment. Grounding systems must comply with the National Electrical Code, or NEC, which provides detailed requirements for grounding and bonding electrical systems. The NEC is updated every 3 years and is based on the latest research and best practices in electrical safety. The NEC covers various aspects of grounding, including the types of grounding electrodes, the size and type of grounding conductors, and the methods of bonding different metal parts of the electrical system. A grounding electrode is a conducting object that is used to establish a connection to the earth. Common types of grounding electrodes include metal underground water pipes, ground rods, and concrete encased electrodes. The grounding electrode system must be installed in accordance with the NEC requirements and must provide a low impedance path to ground. The grounding conductor is a conductor that connects the electrical system to the grounding electrode. The size of the grounding conductor must be based on the size of the largest ungrounded conductor in the circuit. The grounding conductor must be made of copper or other corrosion-resistant material and must be protected from physical damage. Bonding is the process of connecting different metal parts of the electrical system together to create a low impedance path for fault currents. Bonding helps to ensure that all metal parts of the electrical system are at the same electrical potential, which reduces the risk of electrical shock. Bonding conductors must be sized and installed in accordance with the NEC requirements. In addition to the NEC requirements, there may be local codes and regulations that apply to grounding systems. It is important to check with the local authorities to determine the specific requirements for your area. Proper grounding is essential for the safety and performance of electrical systems. By following the NEC requirements and consulting with a qualified electrician, you can ensure that your electrical system is properly grounded and protected from electrical hazards. Electrical systems and their installations often involve complex concepts such as impedance, voltage drop, and fault current calculations. Impedance is the total opposition to current flow in an alternating current circuit. It is a combination of resistance and reactance. Resistance is the opposition to current flow due to the material's properties, while reactance is the opposition to current flow due to inductance and capacitance. Voltage drop is the decrease in voltage along a conductor due to the current flowing through it. Voltage drop is an important consideration in electrical system design because it can affect the performance of electrical equipment. Excessive voltage drop can cause equipment to malfunction or fail. Fault current is the current that flows in a circuit during a fault condition such as a short circuit or ground fault. Fault current can be very high and can cause damage to electrical equipment and create a fire hazard. Electrical calculations are used to determine the proper size of conductors, circuit breakers, and other electrical components. These calculations take into account the load on the circuit, the voltage, the distance, and the allowable voltage drop. Proper electrical calculations are essential for ensuring the safety and performance of electrical systems. Electrical safety is a critical aspect of working with electrical systems. Electrical shock can cause serious injury or death. It is important to follow safe work practices when working with electricity, such as wearing appropriate personal protective equipment, energizing circuits before working on them, and using properly insulated tools. The NEC contains detailed requirements for electrical safety, including requirements for arc flash protection, lockout/tagout procedures, and safe work practices. Arc flash is a dangerous electrical hazard that can occur when there is a short circuit or other fault in an electrical system. Arc flash can produce intense heat and pressure, which can cause serious burns and other injuries. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Safe work practices are essential for preventing electrical accidents. These practices include avoiding contact with energized parts, using properly insulated tools, and wearing appropriate personal protective equipment. The concepts of grounding, bonding, electrical calculations, and electrical safety are all interconnected. Proper grounding and bonding are essential for preventing electrical shock and minimizing the risk of fire. Electrical calculations are used to ensure that electrical systems are properly sized and protected. Electrical safety practices are essential for preventing electrical accidents and injuries. When grounding a satellite dish and its RG-6 cables, it's important to understand the role of each component and the electrical principles at play. The grounding system aims to provide a low impedance path for fault currents, protecting both equipment and people. Grounding the dish: firstly, the metal dish itself is grounded. This is done by connecting a ground wire, typically 10 AWG copper, from the dish's metal frame to the grounding system of the building. The grounding system is usually connected to a cold water pipe, a ground rod, or a combination of both. The connection to the dish is made using a grounding clamp, ensuring a secure and corrosion-resistant connection. The purpose of grounding the dish is to protect it from lightning strikes and static discharge. A lightning strike can induce high voltages on the dish, which can damage connected equipment, such as the satellite receiver. Grounding provides a path for this voltage to safely dissipate into the earth. Grounding the RG-6 cables. Secondly, the RG-6 cables that carry the satellite signal are also grounded. This is typically done using a grounding block. The grounding block is a small metal device that connects to the shield of the RG-6 cable. The grounding block is then connected to the building's grounding system using a ground wire. The purpose of grounding the RG-6 cables is to prevent voltage surges from traveling along the cables and damaging connected equipment. Voltage surges can be caused by lightning strikes, power surges, or static discharge. By grounding the cables, these surges are diverted to ground, protecting the equipment. Grounding options: the grounding block can be connected to the building's grounding system in several ways. One option is to connect it to a cold water pipe. However, it's essential to ensure that the water pipe is electrically continuous to the earth. This means that the pipe must be made of metal and must be in direct contact with the earth. If the water pipe is made of plastic or has insulating couplings, it cannot be used as a grounding electrode. Another option is to connect the grounding block to the electrical service panel. The service panel is the main distribution point for electricity in the building. It is connected to the grounding electrode system, providing a direct path to ground. When connecting the grounding block to the service panel, it's important to connect it to the grounding busbar, not the neutral busbar. The grounding busbar is connected to the grounding electrode system, while the neutral busbar is connected to the neutral conductor. Connecting the grounding block to the neutral busbar can create a ground loop, which can cause noise and interference in the satellite signal. Best practices. Several best practices should be followed when grounding a satellite dish and its RG-6 cables. Firstly, use copper conductors for all grounding connections. Copper is a good conductor of electricity and is resistant to corrosion. Secondly, use grounding clamps that are specifically designed for grounding applications. These clamps provide a secure and corrosion-resistant connection. Thirdly, protect the ground wires from physical damage. Run the ground wires in conduit or secure them to building surfaces. Fourthly, keep the ground wires as short and straight as possible. This minimizes the impedance of the grounding path. Fifthly, inspect the grounding system periodically to ensure that it is in good condition. Check for loose connections, corrosion, and damage to the ground wires. Code compliance. The grounding of satellite dishes and RG-6 cables is governed by the National Electrical Code, or NEC. The NEC specifies the requirements for grounding and bonding electrical systems, including communication systems. Complying with the NEC is essential for ensuring the safety and performance of the grounding system. Common mistakes. Several common mistakes should be avoided when grounding a satellite dish and its RG-6 cables. One mistake is using undersized ground wires. The ground wires must be sized according to the NEC requirements to provide a low impedance path for fault currents. Another mistake is using improper grounding clamps. The grounding clamps must be specifically designed for grounding applications and must be compatible with the materials being connected. A third mistake is neglecting to protect the ground wires from physical damage. The ground wires must be protected from damage to ensure that they remain effective. A fourth mistake is creating ground loops. Ground loops can cause noise and interference in the satellite signal. They can be avoided by connecting all grounding points to a single grounding electrode system. Safety considerations. When working with electrical systems, it's important to follow safe work practices. Firstly, always de-energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, use properly insulated tools. Insulated tools protect you from electrical shock. Thirdly, wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Personal protective equipment can help to prevent injuries in the event of an electrical accident. Troubleshooting. If you are experiencing problems with your satellite system, such as poor signal quality or electrical noise, it's possible that the grounding system is not working properly. Here are some steps you can take to troubleshoot the grounding system. Firstly, inspect the grounding connections to ensure that they are secure and corrosion-free. Secondly, check the ground wires to ensure that they are not damaged. Thirdly, test the grounding system with a multimeter to ensure that it is providing a low impedance path to ground. If you are not comfortable working with electrical systems, it's best to consult with a qualified electrician. A qualified electrician can diagnose and repair any problems with the grounding system. Understanding the principles of grounding, following best practices, and complying with the NEC are essential for ensuring the safety and performance of satellite dish and RG-6 cable installations.